Hi there, this is the first graph of the first parabola that you need to be very aware of, because this particular base graph, y equals x squared, is the most basic parabola, and it's our home base one. So if you take a bunch of x's and put it in a table and find the corresponding y values, we're just going to find numbers that we can produce for different values of x. So if we had x as minus 3, minus 3 squared is our y, which is 9. Minus 2 squared, the y is 4. If x was minus 1, the y is 1. And so on. 0 squared is 0, 1 squared 1, 2 squared 4, 3 squared 9. So you can make a table for anything where you just put these values for x, negative 3, negative 2, negative 1, 0, 1, 2, 3, or similar. You might need a different range because they do shift, but for our basic one, we are centered around 0 for the x, which is here. Now, when you plot these values, the first pair of values or coordinate pair is negative 3 and 9, and on the Cartesian plane, that's this guy here. The next one is negative 2, 4 from here, and that one is here, and so on. What you will notice here on the graph is a series of features that you need to be aware of. So typical features on this graph of x squared and all other parabolas. Now, parabola is the graphed quadratic equation. It's the shape of it. So this guy here is called a parabola. I don't care if you call it a parabola, but it is a parabola. You will notice this. From these numbers here, you can see that they're all positive, because when you square the negative numbers, they turn to positive. So this is a feature of it, and it gives us the symmetry. So around this mirror line here, one of the features actually is the axis of symmetry. In this case, it's x equals 0. So that is always something on a parabola that you will find. The second feature that you will find is the x and the y intercepts. That means where the graph crosses the x-axis and the y-axis. For this guy here, you'll see that there is 1 point, 0, 0, which is actually the origin. And so that is both the x and the y intercept, and that's it for this particular graph, but that's a feature. The other thing you might just take notice of is this one is positive, so that the parabola is this way facing, as opposed to upside down. So this one's right way up for y equals x squared. What else do we need to be aware of? Yep, one more feature that you need to know the name of is the turning point. Now, the turning point is where the graph itself turns around, and that actually is the origin here. So this thing, which is also the y and the x-intercept, is the turning point. And that's where the graph turns around from going down to going up. Okay, so that's your turning point there. Just keep those things in mind, and also keep in mind that you should be labeling these on any graph that you draw. For example, axis of symmetry, you can label as, get the right pen, axis of symmetry, x is 0. You're labeling the turning point, which is sometimes, in this case, this is called the minimum point. Just go on to show you a different parabola, the next base version after we looking at y is x squared. I'm just going to show you this wee little pattern. If you're kind of looking at the shape of the graph, what you'll notice is because these are square numbers and we have the square, 1, 4, 9, here. So because these values here, so we have 1, 1, 1, 0, 0, 1, 1, 2, 4, 3, 9. Because we're squaring them up, we notice that the pattern is this. First of all, from 0 to 1, we go one step out and one step up for the next point. So after 0, 0, it's a 1, 1. The second point along is 1 out and 3 up. And the next point after that for x is 3 is 1 along and 5 up. If you carry this pattern on, you will notice that for x is 4, let's just look at these numbers, 1 up, 3 up, 5 up. The next one will be 7 up. And indeed, 9 plus 7 is 16, which is our next square. So that pattern is really important with sketching when we go to the next skill, that you just appreciate that the parabola follows that shape. The basic parabola follows that shape. The other thing you just need to be a little careful of when you start drawing these is at the turning point, which is the lowest point, it would be, say, there. Your next point's 1 along and 1 up, and after that it's 1 along from there and 3 up, and so on. Just be careful as you sketch the line. Now I've started sketching here beyond the point that I've got. I don't start sketching on the point, and same on the other side, and that shows me or you or anyone looking at the graph that this graph continues. So you don't need the arrow, you just need this little line beyond. As you draw this curve, you need to show a nice roundy bottom. A lot of students, when they start off drawing these, I'll just draw a little thing here, a lot of students kind of do a little V. So I want you to get used to, instead of doing it like more rounded, kind of. Okay, so just be aware of that as a feature. It's a roundy bottom, not a V bottom, not sharp, but round at the bottom. Just getting that 1, 1 nice and curved. Base standard parabola there, that's your base model. So if we have the equation of y equals negative x squared, the values for the corresponding y's for our standard set of x's are all negative. So let's just scratch onto this graph the features of y equals negative x squared. Let's do the axis of symmetry first. It is the same as the other guy, the base graph, the positive one. And so that's where x is 0. And over on my graph, I'm going to label it axis of symmetry. And I've also labeled it just by drawing in these dashed lines. And that's what you want to be doing when you sketch these graphs. So you're going to draw in your axis of symmetry. You're also going to note your turning point. And in this case, our turning point at 0, 0 is also our maximum, not our minimum, our maximum point. It's the highest y point. Okay, sometimes we call that the vertex. Okay, and so that is just this point here, the corner, the turning around piece. And so that's what you need to be aware of for this. Another thing that you should be aware of, and I'm going to go back to the previous graph. Okay, so we have the next one was the upside down one, and I had a negative in front of that equation, and it has almost the same features. It has a curvy vertex, a curvy bottom, and everything is labeled. I haven't put turning point there, but in a way, the textbook has noted the 0, 0 here. And so that is an indication of our turning point. So our maximum type of turning point. So there's two types of turning points. I'll leave this video here so that you understand the parabola. And the end that I was saying is, can you see if you can plot these 4 graphs here? You can use technology, or if you have a printer you can print them out. So the first one is x squared minus 1, part A here. So what you need to do, if you're going to use point plotting, is you need to come up with, they're actually given it to you. So you're just going to go -2 squared take 1, which is 4 take away 1, which is 3. The next value, when x is -1, the y is -1 all squared minus 1, which is 0. Okay, so our first plotting point is -2 and 3, and the next coordinate point that we plot is -1 and 0. When x is 0, y is 0 take 1, -1. So can you do these? I'm going to stop the video, and if you can try these, oh look, before I stop it, I'm just going to plot those 3 points that I did. So on my graph here, I'm going to put -2, 3, my first point. So it's -2 along, 3 up. Okay. Next point, -1, 0, which is there. Next point, 0, -1, which is here and there.